one use of the heap is creating a dynamic array. Okay, so the examples given when we had our discussion of arrays are all static arrays. So meaning to say the size is fixed at compile time. So if you declare your array to have a size of 50, so that will be fixed during compile time. So if you store elements greater than 50, you cannot do it because the maximum size is only 50. So the size therefore cannot be expanded, or it cannot be reduced anymore since it's already fixed at compile time. So the good thing about dynamic arrays is that it's flexible, so it can accommodate the number of elements the user wants. But the thing is, you have to allocate that memory from the heap by requesting it through malloc. Okay, so here's an example of how to create a one-dimensional dynamic array allocating the memory from the heap through malloc. Okay, so here in main we have a pointer variable p which points to an integer, and we have the variables n and I. So prior to allocating the memory, we ask first the user how many elements does he or she wants to have in his or her program. So if the user inputs 5, then the value of n here is 5. Then using malloc, so as you can see here in our argument to malloc, so it will allocate 2 bytes of memory using size of operator. Okay, then multiply it by n. So since n is 5, so 5 times 2 bytes each, so 10 bytes of memory will be allocated from the heap, and the address of that memory from the heap will be stored in our pointer variable p. Now do not forget to cast it to a pointer to integer, because the data type that malloc returns is void. So do not forget to cast it. Okay, then using a for loop here, we can now input elements to our array. So our array here has 5 cells of 2 bytes memory each, and it's not allocated from the stack but from the heap because we use malloc. So if the user wants 10 elements, then you can allocate 10 times 2 bytes each, that's equal to 20 bytes of memory from the heap, and you will have 10 cells of 2 bytes each. Okay, so using the for loop here, so you can input the elements to be stored in your dynamic array. Okay, then if you take a look at our scanf, so it will just indicate there, you can just indicate there p plus I. So p is fixed, it will contain the address of the first memory cell that is allocated from the heap. Only the I changes for each iteration. So meaning to say, at I is equal to 0, if the base address is 100, so the value of p here will always be 100. So at I is equal to 0, so you have here 100 plus 0, and the value entered will be stored in the first memory cell whose index is 0. Okay, or the address is 100. Then second iteration, at I is equal to 1, then the scanf here will have 100 plus 1. So 100 plus 1 offset, so the value entered will be stored at address 100 plus 1 offset, which means the address 102, because assuming that our machine here allocates 2 bytes of memory for integer, and so on. Then to print the elements stored in our array, then we will just use the dereferencing operator as follows. So we will use the same syntax but use a dereferencing operator. So first iteration, at I is equal to 0, P here has a constant value of 100, and again only the I changes, so 100 plus 0 is 100, and using the dereferencing operator, we dereference the value stored at address 100. So at next iteration, I is 1, so this becomes 100 plus 1 offset, and the address of that is 102. Then using the dereferencing operator, we will dereference the value stored at address 102. Okay, so that's how we create a dynamic array. So it's flexible, as I've said, because you can specify the number of elements you want, and it's memory saving because no memory is wasted, unlike static arrays. How about creating a two-dimensional dynamic array? Okay, so when we discussed two-dimensional arrays before, if you notice, when we pass the array to a function, the function should have a parameter that will accept the number of rows and the parameter that will accept the number of columns. Okay, and you have to indicate there in your parameter the size, or I mean the dimension of your array. If it's 2 by 3, then you have to put there 2 for the first dimension, but it's actually optional, and 3 for the second dimension in your parameter. Okay, but in dynamic arrays, this is how we do it. So again, the memory that will be allocated will be from the heap. Okay, so here we declare a variable PTR that will hold the address of the memory that will be allocated from the heap. So R here will be the number of rows, C to hold the number of columns, I for the row index, and J for the column index. Okay, so prior to storing the elements in our two-dimensional array, we will ask first the user how many rows and columns does he or she wants. Okay, so supposing the number of rows is 2, so the value of R here is 2, and the number of columns is 3, then the value of C here is 3. Then using malloc, the syntax will now look like this. So since it's still an integer, so it will allocate 2 bytes of memory for integer and multiply it with R times C. So given that R is 2 and C is 3, so you will have all in all 2 times 3 times 2 bytes of memory, and that's equal to 12 bytes of memory. So basically what you will have is 6 cells of 2 bytes each. Okay, the first 3 cells will hold the elements in the first row, and the next 3 cells will hold the elements in the second row. Okay, and again, do not forget to cast it. So the address of the memory that is allocated from the heap will be stored in your pointer variable PTR. Okay, now to store values in your dynamic array, so since it's two-dimensional, so we need a nested for loop. So the outer loop will be for the row counter, and the inner loop will be for the column counter. Now take note of our scanf. So take note of the structure. It is very important that you won't mix it up. So it should always be like this. So PTR plus the value of I times C plus J. Okay, so you cannot interchange the variables here. So it should always be like this. PTR plus the row number, the current row number, times the number of columns plus the current column number. Okay, so just for your own benefit, it's better if you memorize it. Okay, so PTR plus the current row number times the total number of columns plus the current column number. So if you do it this way, so the element will be stored in the correct cell. Okay.